Hi everyone, this video is an exercise 13C, the challenge question, question number 2. So the second question is very similar to the first question, with some slight differences. So we again have a set of curves with equations y is equal to f1x, f2x, and so on. And they all pass through the point 0, 1, and they are related by the property that the first derivative of the function, let's say f of n, f dash n is equal to fn minus x. So it's basically saying that the derivative of the current function is equal to the previous function. So if you consider a sequence, the derivative of the current term is equal to the previous term. So we are given that f1x is equal to 1, and we want to find these three functions. So at the start, we just write the condition. So the important thing is that f1x is equal to 1. And based on the information that we are given, we can conclude that f2-x is equal to f1x because the derivative of the current function is equal to the previous function. So we want to find f2x. We can then substitute 1 into this equation. So we have f2-x is equal to 1, and in order to find f2 we need to integrate 1. So f2x is equal to the integral of 1 with respect to x, and we simply get x plus c. So now for the constant of the integration, we should use the fact that all the curves pass through the point 0, 1. So that means we can substitute 0, 1 into the equation of every function, every curve, and find the find the y-intercept. So we just need to substitute that 0 into x and 1 into the output, which is f of 1. So we have 1 is equal to 0 plus c. Again, the reason I did this is just I substituted y is equal to 1 and x is equal to 0 from the question. So we just substitute, and c is equal to 1. So that means the function f2x is equal to x plus 1. That's the first function. Okay, now we want to find the third function. So again, we use the relationship that the current function, in this case, let's say the third function, is equal to the derivative of the the derivative of the current function is equal to the previous function. So the previous function is f2x. So once again, we have some integration. So instead of f2x, we write x plus 1. And now we want to integrate that. So we integrate x plus 1 dx, which is simply a half x squared plus x plus c. And for finding the c, once again we substitute the point y is equal to 0, x is equal to 0 and y is equal to 1. So we have 1 is equal to 0 plus 0 plus c, so c is again 1. So f3x is equal to half x squared plus x plus 1. And finally, we find f4x. So we use the relationship that f dash 4x is equal to f3x. And that means f dash 4x is equal to half x squared plus x plus 1. And we just need to integrate that. So we have the integral of half x squared plus x plus 1 dx. And we get 1 over 6x cubed plus a half x squared plus x plus c. And again, when we substitute the point 0, 1, the y-intercept is just equal to 1. So f4x is equal to 6 x cubed plus half x squared plus x plus 1.